Good morning, everyone. My name is Varun. Today, I'm going to present my project, which is on customer churn prediction in banking using machine learning models. Now, let's move on to the table of contents in my project. It has background and objective. First, I'll start off with that. Then I will be going about what dataset I used and its description and the different preparations I've done for the dataset for the analysis. Later, I'll be going on through the EDA, which I've done, which is exploratory data analysis. Then I will be talking about modeling and results. Then I'll be talking about feature importance, which I have done. And at last, I'll be talking about the conclusion and references. Now, let's talk about the background of this project. In today's competitive banking landscape, the ability to predict and manage customer churn has become very vital because there are many banks which provide competitive offers to customers. Many customers tend to switch between banks. So it's very crucial for banks to know which features are very important so that they can retain their customers. So I have done an analysis which allows banks to use the user data which they have so that they can know which features have the most or more likely to contribute to the customer churn. Now, basically, customer churn is something where a person leaves a particular entity. It is called churned. Now, let's move on to the objective of my project. The objective of my project is to develop a machine learning model which is used to predict customer churn. So it basically says a customer is churning or not churning. It's basic classification problem. So for this, I have basically used the three types of machine learning models, which are naive Bayes, decision tree, and adder boost. Now from these three machine learning models, I have done initial analysis. Now I'll be picking one machine learning model which got the best results using my metric evaluations. After that, I have performed hyperparameter tuning and cross-value validation for this best model. Later, I have taken this best model and have selected my features, most important features. So that was my objective of my project. Now, moving on to the data description. The dataset which I used is from a banking sector from three different parts of from three different countries in Europe. Now, this dataset contains 10,000 records and it contains 18 distinct columns, which means 18 distinct features. Now, you can see from this from the slide that this is an example snapshot of the head of the data frame. Now, moving on to the data preparation, which I've done. First, I've checked for duplicate values, which I have found none in my dataset. Then I have checked for missing values as well. Even there are no missing values in my dataset. And then I have performed feature engineering, where I have the first thing which I've done is to group the age column into different age groups. I have built the aging. Then I have done feature engineering for other things like converting countries which are in actually text form to binary format. I have done various encoding. I have used various encodings like one hot encoding. Now this dataset was taken from from Kaggle, from one of the Kaggle sources. Now moving on to the exploratory data analysis, which I have done. You can see there are some 5 visualizations which are present here, which basically says about my dataset. I have done mostly most exploratory data analysis related to the customer churn. The first graph you can see here that the males have less churn when compared to females. In the second graph, which is a histogram of credit score versus churn status, you can see that people usually churn when they have less credit score. You can see another bar graph here, which shows, which is basically our data set, which says that our data set contains approximately 8,000 points of retained customers and 2,000 points of 2,000 or around 2,000 points of non-retained churned customers. We can identify various summary statistics from this box plot and line plot as well. Moving on to the correlation matrix which I've plotted, which is a heat map of feature correlation. This says that there are not many features which are closely correlated with the churn, which is target variable here. This shows that we need to use models which usually perform better in non-correlated environments. Non-correlated environments in the sense when there are more non-correlated features when we do with a target variable. So moving on to the models and results. First, what I have done is I have splitted my dataset into testing and training sets. I have used 70 is to 30, which is 7 is to 3 ratio for splitting the data. I have done initial model analysis for three models I have said before, which is naive base and decision tree and add a boost. Then after that, I'll be performing cross validation and hyperparameter tuning for the best model, and I'll be evaluating that model. So this is the train and test split which I have done. Initially, we can see that this data set has around 8,000 non-churned values and 2,000 churned values, which shows that the data set has a class imbalance. So to rectify this class imbalance, I use SMOT, which is oversampling using synthetic methods. So uh, after using this, my data set is balanced with around 5,500 to 5,500 values of both non-churn and churn. So after doing oversampling using SMOT, I have done the initial analysis. And these are the results which I've got using the initial analysis. From this table, you can see that I have compared with various evaluation metrics such as accuracy, recall, and awk. You can see that from all of these three models, AdaBoost was performing better than all of the other two models. So I have picked AdaBoost to continue my analysis. Now this is the cross-validation and hyperparameter tuning results which I've got after doing it for the AdaBoost model. You can see that the cross-validation after hyperparameter tuning in AdaBoost was around 99.9, which is a very good score. The recall and rock have a score of 99.9, which is near perfect, which shows us my model is performing very well. Now coming to the confusion matrix of AdaBoost model. This confusion matrix shows various values like true negative, false positive, and true positive. So this is also very useful to say whether my model is performing good or not. According to the results which I've got, I can see that my model is performing really well. Now, I have picked this AdaPush model to select which features are most important for customer churn. Based on the observation which I have seen that the features complaint, estimated salary, and credit score are very important for customer churn. So it can be said that banks need to focus on these three parameters when they want to retain their customers. So you can see that feature importance is very useful for banks to analyze which features are more important to retain their customers. Now, coming on to the conclusion of my project, I'll be summarizing what I've done. As I've told you, I have started off with the data set which has 10,000 points. Then I have split it into 7 is to 3. Then I have done SMOT using SMOT oversampling. Then I have performed three different models. I have used three different machine learning models like naive base, decision trees, and AdaBoost. AdaBoost was my best model. So I have used that model to go under hyperparameter tuning and cross-validation, which gave me near perfect results of around 99.9% accuracy. After that, I have went for feature important analysis where I have seen that complaint, estimated salary, and credit score were the most important features. Now moving on to the future directions of one project, I can say that I can extend my research using different dataset with more points. I can integrate various factors as well. And I can say that I can use various other machine learning algorithms and even deep learning algorithms from the project. These are some of the references which I used for my presentation and for my project. Thank you.